will the difference in the market be with chiplets between 2023 and 2029?
Since it's a market question, I guess I'll just jump in first. So the difference in the market is that we're at a stage right now where the dominant players are those that are in the high performance compute space, high performance computing, servers, desktop processors, moving towards edge computing devices, and they're quite predominantly characterized by proprietary solutions. We'll start seeing a lot more applications that can benefit from chiplets as they become more affordable in terms of the manufacturing process. So the trickle-down effect will be those applications that also require high performance but maybe a little more price sensitive. For example, industrial edge computing devices, even smartphones and tablets are all going to start showing up on the radar by 2029.
So I believe by 2029, we'll see sort of a few things that happen. First of all, we'll see more of the quote-unquote individual companies, but large multinational corporations that internally have many sort of substructures and subdivisions. We'll see them sort of create their own internal chiplet ecosystems. That kind of help them build larger categories of products. I think I'm very confident that'll happen. I think we will similarly see that there's a number of startups that were early pioneers in the sort of chiplet space that have developed their own standalone chiplet products that essentially have collaborated with 1 to 2 other or 3 exact number TBD. They've collaborated with some other number of key strategic partners and have realized essentially product families that that they're able to very sort of successfully leverage to meet individual product categories and strategic needs. So I think all that by 2029 we'll have seen not only sort of the birth of all those, but we'll see commercial success of that actually being out in the world.
So from our point of view, what we see is the big companies who used to rely on general purpose computing before are bringing in their own silicon. So this is building their own custom silicon for their own custom needs. But for any silicon, we all know that it takes an army to build a silicon. Most of these companies, it's not their value proposition. Their value proposition is in a very niche piece of logic, but rest of it, they would rely on the ecosystem.
One challenge that we have faced in the chiplet ecosystem is manufacturing support. It's available to very niche market or people who have deep pockets. By 2029, I'm imagining and counting on we will have accessible manufacturing that will be available to startups and smaller companies who will build value-added products using silicon from different suppliers. So in addition to what Elad mentioned, that there is an ecosystem that will be built within one company, that is now very clear to us that we have this open chiplet economy, and we have a lot of hopes for that happening by 2029. I think that would be exciting.
Okay. I have 2 questions that are things sort of put together. One of it is, how should a company be supporting their chiplet? And do you think that the IP that's typically used in this space is going to be replaced by chiplets?
So there are 2 ways to look at it again, right? I think depending on what your application. So we are in the IT business. As I had alluded earlier, we have a number of customers who are trying to vertically integrate their own custom solution. In that case, their expertise is not building. They would rather just focus on that piece of logic that they want to and get that solution out quickly. To address that problem, we actually took a bunch of our IPs and integrated them and just provided that as a product. It's a compute subsystem that we announced last year. We have a case study where a customer could save almost 80 engineering years and get to product using that quickly. Right? They just focused on their piece of logic. So as more and more companies will be looking at it, they'd like to see how can they offload things that they don't add value to their product. Right? Things like what I just mentioned, but there are more components to that. And then, so yes, the answer to your question is, there is a scenario where people would like to just get chiplets completely from their portfolio, but there are also scenarios where people think that they would create some scenarios of just by taking IP. So we do support both the models from our ARM's perspective.
Yeah, so I can chime in a little bit there too. I think a lot of this sort of circles back to the sort of the question that keeps coming up, which is, okay, well, what are the functional partitions that different players have come up with in different sort of markets, and what do those imply about what pieces fit in as quote unquote IP, right? One could certainly imagine a world where things have been partitioned into, okay, there's a predefined set of SerDes IOs, whether it's Ethernet or PCIe or whatever, and there's a separate set of things that are the memory chiplets. One could also imagine a different partitioning where, oh no, actually, there's an IO hub that integrates all of those things, and a CPU defined this other way, right? And all of those are valid in different markets for different reasons. So I think, as Shrew pointing out, I think both are going to continue to exist, because I don't think that there's at least at the moment, a known partition that the world has agreed on, and you decide, okay, well, even if this gives me worse cost in case X and not in case Y, that we're not there. I don't believe we'll be there for a while.
So by 2029, I can imagine one new business model, which will be this concept of just-in-time manufacturing of soft chiplets, which will basically be looking very similar to the soft IP of today. However, they will just get converted to a physical good as soon as the order is there, but the IP is very well understood and potentially even manufactured and silicon validated.
You can think about companies who have a roadmap of multiple products, actually build a few chiplets and create their SKUs by combining a number of those chiplets, right? I think that's a perfectly valid solution there. So think of server player, for instance, right? If they want an instance or something like that that has X number of cores, right? They just have that solution ready. But if they want something that they want to build in a DPU kind of a thing, right? They take the same CPU, add their DPU logic to build a DPU. Right? So all those scenarios are possible where you're actually reducing the number of tape outs to create, but expanding the number of SKUs in your product.
There's been a good bit of discussion about security. Where do we stand now, and where do you think we're going to be in 5 years? Is this something that is going to get some level of standards? And what different areas is this going to be affecting chiplets in terms of their design and implementation?
First of all, there is no one-size-fits-all in terms of security, even on today's non-chiplet based solutions. Security is one of those risk analysis type choices that you have to, it's a very economic choice. You invest only as much in the security as is better than your competitor. If you put too much investment into the security, you're going to wind up pricing yourself out of the business. If you don't put enough in it, you risk your brand and reputation and potential liability. So there's a lot of evaluation there in just how much security do I need to be able to produce this product at the risk assessment that is natural and serves the market. That's not going to change for chiplets either. What will maybe change for chiplet technologies in terms of security is there's going to be a lot more emphasis on your relationship with your suppliers, because the chiplets themselves are theoretically even a little easier to clone. If there's a very simple function or something that you're getting a chiplet manufacturer delivering to you a particular chiplet, you may not be able to recognize that you've gotten the exact chiplet that you were expecting, and it could be a clone or something like that. So there's a higher risk for chiplets because the ability to clone a function is much easier than the ability to clone an entire system level solution. So that's one aspect of the security. The other aspect I've heard is, well, do we need the chiplets to be able to securely speak to each other and be authenticate to each other so that we know within the chip that all of the chiplets are exactly the ones we expected to be there? I really don't foresee, once you have designed an SoC or an ASIC and you've already built the chiplets in there, there are too many different security attack vectors to worry about that whether somebody stripped down your chip and somehow inserted a substitute chiplet into that. It's just not realistic that that's a real security threat. But there is a definite security threat. But there's also an opportunity here in terms of security. We will potentially be able to allow companies that's what they do. They specialize in security. They know all of the communications regulations. They know the encryption, decryption at its best. They know authentication. They know safe boot processes. All of that could be in the hands of somebody who really does it right, producing a chiplet that you could then add to your system on chip solution or your ASIC and not have to necessarily worry about it if that chip controls communication in and out of the chip or protects it from side channel attacks. I talked a little bit at the conference about the potential for adding a chiplet that just randomly produces regular reiterative patterns so that you could potentially disguise your keys from side channel attacks. These are all solutions that may be available from a chiplet-based economy.
So from a security perspective, there are two angles to look at, right? Which can already address. So one is supply chain. Do you trust your supply chain? How do you make sure those chiplets that are in the package? So that you need to make sure you're able to attest those supply chains. In some of the industries we cater to, that thing could be done, right? It could be not when the package was built, but it could be 3 years from now when the system is still running and somebody wants to do an audit. They need to know where that, before they even put a worker on. But the second concern is your applications. Today, more and more, it's a data-driven world. So user data is all over the place. If your chiplet is going into a solution where user data is touched, then you better make sure that data is not leaked through your chip. So confidential compute is a paradigm that's being pushed in the industry, and that more and more is addressing this problem. Right? How do you make sure you're compliant, your devices or chiplets that you're building are compliant with the confidential compute architecture, and not only from side channel attacks, but also from software and soft attacks.
The additional security concern introduced by chipletization is primarily related to supply chain security and trustability of the material that was used to build a chip. Technical solutions do exist to solve that problem, but a clear standard that a chiplet vendor that they can adhere to does not exist, and that's a gap. And we hope that somebody will put out a standard and that becomes popular and people start complying with that.
And I think Tom was pointing this out. You know, if you're in the world where there's a fairly customized SoC that you've just aggregated into an SIP, there's a fairly high technical hurdle for somebody to go and figure out, okay, well, what the heck is this chiplet and what is it doing? And I think when we get to a world of true plug and play, you know, now we've intentionally made that barrier lowered, so security becomes actually that much more of a first order constraint on, you know, okay, well, you've specified this data sheet, you know, how do you know it's doing what you actually intended it to? Because you've told the world what you're actually, you know, what you're trying to do.
What do you see as some applications that are going to be coming about in 2029 because of the availability of chiplets that we don't necessarily have now. For example, if you had a very large analog chiplet, you could do some very interesting radar processing.
I certainly think that we will initiate new design changes, but again, 5 years is not very long. If they're not already working on it today, they're probably not going to have a solution by 2029 in terms of a brand new application that that is being enabled by chiplets. Right now, we're really just working on, can we do what we currently do more efficiently by utilizing chiplets? And then once we move beyond that point where the answer is, well, yes, we're doing it, then we're gonna start seeing a lot more innovation about, well, now that we can do it, what can we do with it? And certainly AI is going to be a driving force behind that. We're not going to see an end to classical processors, but the massive growth opportunity for the semiconductor industry right now are all the different applications that we have to ask ourselves, could this be more efficiently done in AI, with an AI application accelerator in the process? The big data transmissions is where we're looking at, and that's telecommunication applications, large carrier-based router switches, computer-to-computer, clustered computer systems and data centers. Those are all primed for those optical solutions.
Traditionally, if you look at historically, any semiconductor company, a semiconductor startup, required quite a lot of funding. That's primarily to hire a lot of experts to build that solution. To begin with, there are not enough people with that skill set. I mean, there are only so many of us out there, right? So that basically stalls the startup innovation. With chiplets and that framework, you don't need that large an army to build new solutions. You can explore new solutions with a smaller headcount of engineers while relying on the ecosystem for the other components, the non-value add components. So I believe there will be an opportunity to explore new spaces that haven't been explored before because of the cost and failure concerns.
So I believe that chiplets will unlock system level miniaturization, which is along the same lines that where people are innovating using printed circuit boards today. They cannot achieve small form factors or low power, or maybe combine sensors with inference.
And just to add on top of that, I think wearable devices might be one of those places where you see that miniaturization take hold with a chiplet-based technology, where we will see some very interesting things in wearable devices.
There's some other interesting aspects about this too, because one of the things that we're finding in AR, VR is that, you know, the human sense of where you are, and when you've got glitches happening in the system because there are failures or rerouting or whatever else, it really messes up the experience. I mean, to the point where it's just not quite fast enough latency-wise, you get seasick or whatever else when those things too high. But there's another interesting dimension to this, which I think ties in with wearable devices, and that is that you can build a very different kind of timing domain that can be, I had to say to use the word coherent, but because that could be confusing cache coherency from, you know, quantum coherency, but there is a different way of thinking about the temporal experience of a human being, and I think that really does open up a vista of opportunities for innovators.